Hello! We have chosen the golden number because it is the one that intrigued us the most.
The number represents both a formula and a proportion of perfections,
which can be found more or less everywhere. In mathematics, it is the positive real number denoted phi. It is an infinite and irrational number which is given by the formula. In geometry, phi is a ratio of proportion between two elements which is worth this number. Two lengths A and B are said to meet the golden ratio if the ratio of A to B is equal to the ratio of A plus B to A. Now take two lines, one of length 1 and second of length 1.618. It doesn't matter what the unity of measurement is, since the ratio of proportion between two is 1.618. We can say that they are related by the golden ratio.
The golden ratio has some interesting mathematical features. For example, when you multiply phi by itself, it is the same as phi plus 1. Take a segment of unit 1, multiply it by phi. This gives a second segment of length 1.618. If we multiply this second segment by phi, we get a third segment of length 2.618, whose length is equal to the sum of the lengths of the second segment. This is valid only if the lengths of the first and second segment respect the golden proportions.
A golden rectangle is a rectangle which respects the proportion of the number, for example, of width 1 and length 1.698.
The same applies to an isosceles triangle with side 1 and base 1.618 or with base 1 and side 1.618. These are called golden triangles.
The regular pentagon is a geometric shape that naturally has the golden ratio. If the side is 1, the diagonal is 1.618. By connecting all the points of the pentagon, we obtain a star, which also shows the golden ratio. The golden ratio is very much present in the pentagon and its star. Some believe that this is why the pentagon has been widely used as a mystical symbol in many esoteric practices.
The golden ratio is also found in the Fibonacci sequence, which are sequences of numbers where each value is the sum of the two preceding ones. In this sequence, you find phi in the approximative way. To do this, you have to divide a term by its previous one. For example, 13 divided by 8 is equal or 1.625. 514,229 divided by 317,811 is equal to 1.618. But let us specify here that Fibonacci, who lived in the 30th century, had not realized that by dividing a term of this sequence by its preceding one, we obtain the golden number. You have to use terms that are infinitely far away to be infinitely precise. The golden ratio can also be found in another form. They are also called Fibonacci spiral, which are constructed using this sequence. If you form a square with the value of the Fibonacci sequence as size and draw a logarithmic curve with a magnification factor of 1.618, we obtain a golden spiral.
In some shells, such as the nautile, the development of the shells forms a golden spiral. The golden ratio is found in the pine cone with 8 spirals in one direction and 13 in the other. However, this doesn't apply to all plants. Golden proportion would even exist in the human body, as drawn by Leonard da Vinci in his Virtue of Man, where the distance from the navel to the foot is 1.618, greater than the distance from the top of the head to the navel. But beware, there is danger in seeing the golden ratio everywhere. The thesis of the omnipresence of the golden ratio is often taken up, but in the end the use of this number is rather limited to a few subjects such as phyllotaxy of sunflower or the crystallography of quartz.
So who discovered the number? What is its origin? This is still very uncertain. The proportion 1.618 is found in the pyramid of Cheops, dating from 1500 BC, and the pyramid of Meidum, dating from 2500 BC. But this proportion is most probably the result of chance. The Egyptians had no knowledge of either P or Phi at the same time. Some historians consider that the origin of the golden ratio must be attributed to the first specific study of it, that is, the work of Euclid, the Greek mathematician of the 3rd century, in his work entitled The Elements. In the third definition of the book 6, the golden ratio is defined as a geometric proportion. Euclid speaks of the segment divided into extreme and average reasons. Other historians even attribute the origin of the golden ratio to the work of Plato a century earlier.